right. What I'd love to do in the next 45 minutes or so, I'll leave some room for questions after, just talk a little bit about problem solving, a little bit on fundamentals you need to know, kind of where to go from here. The most important thing to understand is this is a slightly different skill set than just your general programming. So if you can follow a tutorial and build a web application, that's awesome. This is just a different kind of skill. You got to work on this skill set when you're debugging, when you're learning new things, when there's that kind of ambiguity in the learning process. So we'll talk a bit about process for solving problems. We'll give a example problem. Some of you have seen this before, and that's where we want to go ahead and start. Alrighty, for those of you who don't know me, my name is Ellie. I'm the CEO and one of the lead instructors here at Rithm. Started Rithm about 8 years ago, almost at this point, and hopefully you've done a little bit of research if you're at this meetup and you know our deal. We're a coding bootcamp focusing a lot on small class sizes, experienced instructors, real world projects. It's a very tough market out there, but we do our absolute best to make sure we're doing right by students, admitting students that are ready for our program, setting them up to be as successful as possible, and just focusing on the student experience first and foremost. So with that in mind, let's go ahead and hop in. So what are we doing here? We are solving problems like a pro. Welcome. This is video on and interactive, so it's always nice to have your video on. If there are questions that you have, you can always throw it in the Zoom chat. Otherwise, you can raise your hand, and we're glad you're here. What are we going to try to do? We're going to learn some problem-solving strategies. We're going to talk about what pseudocode is and how to write it. And for those of you that have heard me talk about this, you're going to hear it again. And sometimes a little bit of spaced repetition. It's a really nice way to remember things. So you'll hear it again, and hopefully it'll just be drilled into your minds. And then we'll prepare for technical interviews for coding bootcamps. So I'm assuming that you are here because you are looking to either do some kind of interview, some kind of problem-solving challenge, or you are just leveling up your programming skills for the purpose of pursuing this in some kind of professional capacity. Before you can problem solve, this is kind of the disclaimer of sort that we have for this presentation. You got to get your fundamentals down. And we have a lovely fundamentals course. Every bootcamp out there has a lovely fundamentals course. At the end of the day, it's all the same stuff. I'm just going to pop over to about:blank. This is a lovely place where you can open the Chrome DevTools and see absolutely nothing. So it's kind of like a blank little canvas for me to work on. When we talk about fundamentals, what are we really lumping in here? Your basics, variables, data types, conditional logic, your data structures. And this is not data structures, algorithms, all sorts of advanced computer science. This is arrays and objects. Then we got functions. Before you can actually solve problems, you got to know how to use these tools. That would be like building some kind of Lego set without any instructions, and you just have to try to wing it and hope it looks like what you're looking to do. It's not really going to work. Learning this right here is not particularly enjoyable. I'll be totally honest. If you're like, I had so much fun writing 15 if statements every single day until I learned how if statements work, no, that's not a very enjoyable part of programming. But this is what you do when you learn any new programming language. There's a little bit of a syntax hurdle that you have to get over. And fortunately, with languages like JavaScript or Python, it's not too bad. But if this is the first time you are ever doing any kind of programming, there's just going to be a little bit of hurt that you have to go through. You're going to forget the comma after a key in an object. You're going to forget the closed parenthesis. You're going to forget the opening quotation mark. You're going to forget the curly brace. You just got to get that over and over and over again. And that is memorization, hands on the keyboard. That is you coding as much as possible. So that is where the responsibility is on you to just sit down and learn these basics. Variables and data types. What exactly do we mean in this kind of subset of variables and data types? Well, making variables. So using let, using const, just declaring some kind of variable. That's great. Not only what goes on the left-hand side of this equal sign, or we call the assignment operator, but what goes on the right-hand side. What does this actually mean? What is the difference between this and this? If I press enter right now, why will this code never work? Well, I've actually got my debugger to pause when there are things that don't work. So I'm going to go ahead and take that out just to show you this error. But anytime that you try to access a variable that does not exist, you get a reference error. The difference between these two things, this is a string. You're going to make silly mistakes like that all the time, but just building an understanding of what that actually means. I am asking JavaScript to remember this thing called first name. And anytime that I access it, I want you to give me the value of the string out. Your data types, strings, numbers, those are integers and floating point numbers. They're all just one thing in JavaScript. Booleans, what's the difference between this and this? Null, undefined. Things you'll use a little bit less, but just having an idea of what those things are. It's not particularly fun, but that's just the fundamentals that you gotta get down. Conditional logic, if statements, else if statements, else statements, along with this looping. Fortunately, in JavaScript, there are zillions of ways to go from one thing to the end of another thing. You want to go through all the characters in a string. Let's go back to this right here. You might be familiar with your standard loop. I is less than 0, I is less than first name dot length. You're probably gonna have to type this hundreds of times before you don't make those syntax mistakes. And we can print out every single character in this first name. Great. But there's a slightly easier way to do this in JavaScript. You may have seen this before, you may have not. For every character of first name, and I'll just dock this out so we can see it a little bit better. You can call this whatever you want. I could call this taco of first name, but character or car or char, as some people say, is a reasonable name. Let's just print out each one of those. Great. These both do the exact same thing, but being comfortable, if you want to go from beginning to end, you want to keep it simple, this is a nice construct to know about. So that's kind of where we go back to just those fundamentals. You've got to be comfortable with variables, data types, conditional logic. What else do we have in our list? Data structures. This sounds very intimidating, but at the end of the day, you have to know what arrays are, what objects are, and how to work with them. I have some numbers. I want to make sure I know how to remove something from the end, how to remove something from the beginning. What does my array look like? Cool. I just removed the number 4. I just removed the number 1. This is what this function returns to me. I want to go add something to the beginning. Great. This gives me back the length, how many elements this array has. Sometimes just playing around in Replit in the Chrome console, somewhere we can get that instant feedback is really, really, really helpful, because flashcards can be nice for kind of memorizing these things, but nothing clicks until you're actually getting your hands on the keyboard. Because it's not until you do stuff like this or stuff like this where you realize, oh, that's wrong. Well, that's sort of Pythonic way of doing it. This is spelled incorrectly. This is actually where the learning happens. Not when you get it right, when you get it wrong, and then you have to figure out how to do it right. So if you get it right, that's awesome. You've knocked it out of the park, but there's still the part of what happens when it's not right. How do you fix that? So it's not particularly fun. It's not particularly thrilling, but you just gotta, eat your vegetables, or however you want to draw the analogy here. So hammer home that point as we go through it. Similar kind of idea with objects. Got some instructor, data, and here, it's your basic syntax. All your keys and objects are strings. First name of Ellie, last name Shopik, num kids 2, whatever else you want to put inside here. Also getting comfortable with data structures in data structures. My favorite colors are red and purple and green. Accessing these. Removing these keys. Modifying these keys. And if you're looking at this and you're like, yep, I feel good, I can do those things. Awesome, you're in great shape. See if this object contains a key. Does this have a key of last name? Sure does, yeah. Nope, doesn't have it with 2 keys. Can write this in many different ways. Is the key of last name in instructor data? The kind of idea of just knowing how to work with these data structures. Does it have the thing I'm looking for? Where is the thing that I'm looking for in the case of an array where there's ordering? How do I add something? How do I remove something? How do I modify something? How do I swap something? These kinds of basic operations that you just have to know how to do before you tackle more difficult problems. We see this a ton in interviews where folks will get to a point where they feel comfortable, and then come interview time, it's oh, I forgot how to see if a value exists in an array. And you spend a lot of time trying to think of that part, where if you have those fundamentals, you can allocate some more brain space for tackling the actual problem. So really, really, really make sure your fundamentals are in good shape before you start solving any of these problems. Great way to practice this, again, the Chrome console, REPL, any kind of tool where you can just type and get feedback right away. It's really nice just to have a little sandbox to kind of hammer home these ideas here. Again, any questions you have, feel free to throw it in the chat. Raise your hand. Happy to answer as we go through. Get your fundamentals down. Make sure you know the basics. Conditionals, loops, arrays, objects, and functions. In the case of functions, there's a lot of stuff that you can learn about with regards to functions. So you can make a function using the function keyword. Your functions accept inputs. We often call those parameters. You can pass in however many parameters you want. You can call them whatever you want. They're essentially variables, some kind of placeholder. I'll make a function called add, takes in 2 numbers. These can actually end up being anything. In JavaScript, I can't force these to be numbers. I'm basically just saying 2 placeholders and just give me back the result of these 2 things with the plus operator. Can't guarantee that they're numbers in JavaScript. I'm just going to hope that the person calling this function puts in numbers. Functions accept input and they provide an output. You provide an output using the return keyword. Once your function returns, it's done. Anything else after the console.log, whoa, right now, I will never see that console.log. Once a function returns, it has finished executing. So you can put code below it, but it's meaningless. It is never going to be run. So it's these kinds of things that you want to make sure you have an understanding of, because very commonly you'll have lots of bugs. You accidentally return too early, so the code you want is not doing what it's supposed to do, or you forgot the return keyword. So now all of a sudden you're trying to get back these 2 things and you call add and you just get undefined. That's because by default, all functions in JavaScript return the value undefined unless you specify otherwise. You want to make sure that you're comfortable writing functions that accept parameters that return outputs. There are lots of other topics in the world of functions, in the world of functional programming, really, that I would not worry about as much. Things like closure, partial application, currying, they're useful ideas and interesting patterns, but to be totally honest, in the real world in JavaScript, you don't use it a tremendous amount, and it's not super valuable for you becoming a good problem solver. So there's always more to learn about the language. There's always to learn more about the internals and other features and other data structures, but you want to get to a point where you study enough fundamentals to actually do interesting things with the language. So the last thing you can do is, don't spend 3 months just studying the language, and then finally, I feel like I know JavaScript, I can solve problems. No, just get to a good starting point where you can start tackling some toy problems, some more interesting kinds of challenges. So again, it's not particularly fun, but you got to practice, you got to practice, you got to practice. This is actually one of the only times where you really do need to memorize stuff. If you're in an interview with us and you ask us some question like, how do I add something to an array? Or how do I see if something is in an array? That's expected knowledge. If you tell me something like, oh yeah, the method to remove something from the middle, it's splice, and I don't remember the first parameter. That's cool. I'll gladly refresh your memory. So you don't need to memorize every single detail, but you got to have in your mind the 20, 30 or so functions that you're going to use pretty consistently with your data structures, with your strings, and so on. So there's a bit of memorization here, and best way to do it, just get your hands on the keyboard. You can watch all the YouTube tutorials and videos in the world, but nothing clicks until you are actually typing things on the keyboard and running your code. Like I mentioned, tools like the Chrome console, REPL, etc., great place for feedback. Shifting gears a little bit, you got your fundamentals down. You've worked with some arrays, you've worked with some objects, you've started to write some solutions to Code Wars level 8 problems, things that are just asking you to do some very basic things where there's a lot less moving parts to have to worry about. So you've got some fundamentals down, you've worked through R toy problems, Hack Reactors toy problems, CodeSmiths problems, whatever it may be, and you've got a pretty good foundation on the basics. Now you're actually ready to start solving problems. In technical interviews, and I'll give you kind of the hot take here, the hard part is not actually writing code. The hard part is not where does the word for go, where does the loop go, where does the if statement go. The hard part is what comes before that, getting to a solution, talking about a solution, pseudocoding a solution. If you're given a problem and you jump right into the code and your code doesn't work, you're in a lot of trouble because you have nowhere to go. You kind of either have to start deleting your code or start all over again and so on. So in order to solve problems effectively, you have to go a little bit slower to start. You have to have a little bit more process. You have to do a little bit more work before you actually get into a solution. So we're going to propose to you a process for solving problems, whether that's a code signal challenge or a technical interview or any kind of technical problem that you are faced. Here's a great way to do it. And we'll do that actually with a problem statement. You are welcome to try to solve this problem on your own. It's an interesting problem. It's got some edge cases. It's not terribly, terribly difficult, but it's a fun one to use this process on. We're going to write a function called sorted lists. Lists is just another word for array in JavaScript. So if you're coming from Python, we'll use the term list. In JavaScript, a list is basically an array. You are given two already sorted lists. Return a new list of all the elements sorted. So you're given two different lists. Return a new list of all of the elements sorted. If you're listening to this and you're, I see a lot of you looking down, maybe writing something, which is great. Hopefully you're writing something related to this and not some other things and you're paying attention. But if you are paying attention and you're writing things down, which is great, I'm so curious what you're writing. Because if the first thing you're getting to is drawing arrays and writing the word function, and I need to, because I have two arrays and then I need to loop over and an if statement, and I need to return a new array, take a step back. You're definitely going to do that. So it's not like you're not going to solve this problem, but sometimes it is just take a step back. You might be thinking about this, oh, I'll just call sort. So I could do this really easily with sorted lists, and I could take in array 1 and array 2, and I could just, sort each of these, and I can return them together. So I could do something along the lines of return array 1 and concatenate it with array 2. And then let's go ahead and take this whole thing and sort it. You could totally do something like that. There are very fancy ways in JavaScript of, give me an array of array 1 and array 2. There are lots of fancy syntax for sorting this how you want it. And maybe you know that sort accepts a callback and you want to return it in ascending order and so on. Yeah, you could do all that, but don't use the sort method. You might be wondering, why can't I use the sort method? Well, A, because we said so, and B, because using sort is not always the most efficient in terms of how much time it takes to do so. So there's a faster way to do this. And that's, again, not the primary concern, but hopefully should get you a little excited about why you can't use sort to solve this problem. As a kind of preface, this is a skill that takes practice. But you can study smart or you can study a lot. And by having a process in place when you start studying, you are going to make much more progress over a certain amount of time. So you can try to solve hundreds of problems, but if you don't really have a process that you practice alongside solving those problems, when the problems get harder, it's going to be really, really rough. So first and foremost, start with the easy stuff. Make sure you understand the problem. Next, write down a test case. Try to make some kind of concrete representation after you write down that test case. So try your best to not jump to, if the problem is very difficult, arrays of 1s and 2s and strings and so on. Try to talk through the problem without thinking of code. And we'll talk a little bit about a way to do that for this problem. Sometimes that even means drawing something visually. This is also why we have whiteboards at whiteboarding interviews. There's a lot of that kind of diagram or drawing or building some kind of mental model for what you're trying to solve. This will help you get to some kind of plan for solving the problem. This will get you to ideally what is pseudocode. Feel free to throw this in the chat or raise your hand, but what is pseudocode, or what does pseudocode mean to you?
It's kind of just like writing out in plain language, not like using, syntax or whatever, just kind of plain language, like what you're going to do or how you're going to solve the problem.
Excellent.
Kind of like a
Just
step by step.
plain instructions for solving the problem. And you hear that definition, you're like, yeah, that checks out. That sounds good. And then the next question you have is, oh, well, what defines that plain language? How do I know if I'm writing too much code? How do I know if my instructions are short? Two goals you should have with pseudocode. One, you can write that pseudocode and you can hand it to me, and I can write that code in any language of my choosing. You want your pseudocode to not be very language specific. This is not a golden rule of thumb, but this will just stop you from doing things like writing pseudocode that says for curly brace and if something in object and so on. So your goal for pseudocode is, can you take these instructions and hand them to someone else and they'll write the solution in Rust or C or Go or Haskell or Erlang or whatever programming language they choose. Try not to make your pseudocode extremely technical and language specific, because that's going to help you not jump into code and not start thinking of commas and curly braces and semicolons and all those pieces of syntax you need. Second goal of pseudocode is you write that pseudocode, and then a month later, you come back to it and you can solve the problem. So you don't want your pseudocode to be so hyper specific that if you came back to that pseudocode a month later, you'd be wondering, what was I thinking? So keep the instructions relatively high level. There's a reason why we do these things. Hopefully, make sure you understand the problem. There's a reasonable explanation for that. You don't want to solve a problem that is not being asked of you. Sometimes this is as simple as just restating the problem to your interviewer, or just saying, do you mind if I just repeat that back so I can make sure I understand? No one is ever going to say no. In fact, that's always a good sign. It's almost always a bad sign in a technical interview when someone says, all right, I'm just going to start writing some code, because they get one shot to do it. And if they do it and it's not right, then you're basically just starting from the beginning again. Like, okay, well, let's try this all over again. Writing down a test case. What do we mean by writing down a test case? Once you feel like you understand that problem, your test case could be as simple as, and I'm not talking about the syntax for testing or unit testing or so on, just something like, okay, I get two arrays like 1 and 2 and 4, and then I get one that is 3, 4, and 5. So I should return a list that looks like 1, 2, 3, 4, and 5 with another 4 in it. And you can clarify your understanding. Is this correct? Does that look right? Cool. And let's imagine, I have an array that is actually empty, and then I have one that is 1, 2, 3. So maybe this is a little bit an edge case, and then maybe I have, another edge case here. Seems reasonable to me. This also gives you a good opportunity to say, are we dealing with numbers? Are we dealing with strings? Because maybe the interviewer has a different idea. What if there are lists inside of this list? This problem can get exponentially more difficult if you want it to. So really helpful to get a chance to just clarify what's going on here. The other good reason to write a test case is because after you solve this problem, you never want to look at your interviewer and say, I think it works. Because then your interviewer could say something like, I don't think it works. And then you're back at square one. So being able to go back to your code and say, okay, now that I've written this, let me just go walk through what's going to happen in this test case. All right, so I'm going to iterate over this first array, and I'm going to compare this value to this value, and this one is less, so it goes in the new array. And then I'm going to compare the next one, which is 2 and 3, so that goes in the new array. And then I'm going to compare 4 and 3, and 3 goes in the array. Then I'm going to compare 4 and 4. Doesn't really matter, so I'll put either one of those, or maybe I'll put both of those in the array. And then turns out there's nothing left here, so I'll just take whatever is left. Again, I'm not actually talking about any code here, just talking about my approach. But having a test case, having some kind of concrete representation for how I can walk through what this is doing can be really helpful. Again, I'm not even at code. You're going to look at this and say, okay, I have 20 minutes to solve the problem. I need to spend 19 minutes writing code. I'm going to flip that on its head. You should spend 12 minutes writing code. Because if those 12 minutes have pseudocode that is very good, what does that look like? Well, I built this kind of idea. I'm going to start with some pseudocode here. So, maybe the first thing I'll do is make a new array. And then I'll loop through the first array. And then I'll compare each value. Whichever one is less, remove it and add to new array, return the new array. Now this pseudocode is not necessarily complete. There might be some edge cases here, but this just gives me an opportunity to talk through, okay, I'm gonna make a new array, and then I'm gonna loop through the first array. I'm gonna compare each value. Whichever one is less, let's remove it. So maybe I'll just go take this away and then add it to the new array. And then I'll go compare, and this one is less. And then I'll go compare it, and then this one is less. And I'll go ahead and compare it. And then this one is less. It doesn't really matter. Maybe less than or equal to, whichever one is less or equal. Cool, so I can think about that case. And again, I'm not actually writing code. I'm just talking through my process for what needs to be done. And now, oh, wait a minute. I've looped through the first array. I'm actually done looping through the first array, but I realize I can't just return the new array because I have to figure out the rest of this array. So before I return the new array, I should just make sure to add the rest of whichever array is remaining. In this case, it's going to be pretty easy if I have the first one. So I might need some kind of check for if the array is empty, then go ahead and just add the rest of it on there. So that's an edge case I might need to think about. Maybe I'll make a test case for that where I actually have something like 4, 5, 6, 7. So now I can compare these, and I'm going to end up doing 1, 2, 3. Then I'm going to realize, oh, there's nothing left to compare here. And if there's nothing left to compare, then just go ahead and add all this stuff right. I'm not spending a lot of time in this process, but I'm thinking about some edge cases. I'm making sure that my code does what I want it to do. And I'm talking through my approach as I go through. Again, I'm essentially kind of talking to myself as I'm thinking about solving this, but I'm looping my interviewer into what I'm thinking and what I'm doing. The good news right now is there might be a couple pieces of syntax that I need to fix, but now I've got what I need to write code. And the more that you do this, the faster you will get at it. But again, you never want to go too fast. So if you can walk through to your interviewer in whatever context, sometimes if it's a code signal challenge and you're by yourself, talk to yourself. It goes a really long way. What am I trying to do here? Let's go make a loop. Let's go write some pseudocode. Because right now, it's not a lot of code for me to make this happen. If I got my fundamentals down, if I know how to check for lengths of an array, if I know how to loop through arrays, if I know how to compare values in arrays, if I know how to make new arrays and return them, this should be relatively easy for me to do. So again,
it seems like a pretty important thing to be able to run through, and they can obviously understand that, okay, this guy knows the thinking process of going through something, by the way you're saying you're talking through, you're going through it. It's not necessarily about like, yeah, you're not writing code, you're not this and that, but it becomes very clear. It's like, all right, this guy knows what's up. And like that's an important thing to show in such a situation.
I'll talk about this a lot there. Partial credit goes a ridiculously long way in technical interviews. So if you have a limited amount of time and you get to the pseudocode and you don't finish writing the code, but your pseudocode is correct, or maybe there's a bug that you forgot about or so on, that is always going to be more towards a pass than you wrote a bunch of code and it mostly works, but there's still some bugs and the interviewer is thinking, this person's probably not a great problem solver because they just wrote a ton of code and when things are wrong, they're going to have to go back and change things. This is kind of how I would think about a nicer way of solving a problem. The opposite of this would be all right, let's go ahead and write a function. Okay, so I need a function that sorts sorted lists, and it takes in 2 arrays. And then I'm going to make a new array. So I'll call that, my sorted list. And then I'm going to loop over each of these arrays. So as long as there is anything in this array, I'll go ahead and compare if array 1, and actually I guess I'll have to make some kind of variable here to keep track of those things as I go through. So let's go make a variable here called I, and then we'll start that at 0. And as long as array at I is less than array 2 at I. Then we'll go ahead and add to the sorted list. We'll add that at the beginning, array 1 at I. And then, just the talking that I'm doing right now, your head should be spinning. You should be hearing me and being like, what the fuck is this guy talking about? And honestly, I'm actually writing some code that for the most part is pretty accurate. There's a lot of stuff that is correct here. There's still some, and then I could say, oh, and if that's not the case, then let's go add a array 2 at I, and then we'll go ahead and then we'll remove that. So we'll, take array I and we'll remove the first thing. And then we'll go ahead and remove this thing. And then, okay, so I'm going to loop over the entire array. And then at the end, I'll just check if array2.length is greater than array1.length, then we'll just sorted list and concatenate array2 onto it, and then we will return the sorted list. Okay, this looks pretty good to me. Look at that. I just fired off this code in what, 2 minutes, 3 minutes? There are at least 5 or 6 bugs in this code that you might be looking at. I'm not incrementing I, I'm not, I'm comparing things against undefined. I'm not storing the result of what I concatenated. There's just endless amounts of bugs that go on here. And the problem is, if you get to a point where you're like, okay, I think this works, and the interviewer says, no, that's not exactly it, now you're in a really bad place. The number one thing you want to try to avoid in technical interviews is deleting code. Only delete code unless you're really sure it is the thing that is causing you trouble, because it turns into this spiral right here. Oh, actually, instead of a while loop, I know what I need to do. I need to do a for loop. So for let I is 0, I is less than array1.length, I plus plus. That while loop that I had was mostly correct, but now I'm going to spend a lot of time, a lot of resources, and a lot of mental energy in trying to figure out how to redo everything that I just did. And I have no pseudocode. I have no life raft. I have nothing to look back on and say, oh, what was I actually trying to do here? So jumping into code, unless it's a very simple problem and you're like, I can do this in my sleep, I feel super confident, which is going to be very rare as the problems get harder, you need a process. So this idea of just kind of jumping into code, it really doesn't work, to be totally honest. And that's why many engineers, when they build things, talk a lot before they build those things. It's pretty rare that someone's going to give you some task to build in the real world, and you're going to put your headphones on, you're going to write code for 3 days, and then you're going to come up and say, look at this beautiful thing that I've made. So there's a lot of communication, a lot of just thinking through what actually needs to be built. And it starts with this kind of stuff. It's why we assess for problem solving. It's why companies assess for problem solving, because it's just a really, really important skill to have when being any kind of software engineer. So make sure you have a process that you don't end up in this situation. And then all of a sudden it's oh, actually, this is so silly. I don't want to use an array. I want to use an object. And now you're in this really gnarly rabbit hole of the wrong data structure, the wrong choice, the wrong everything. And you've just burned, minutes, and your head is spinning and your heart is racing and you realize, oh my God, I'm failing. So process goes a really, really, really long way here. It's going to take some time to get comfortable with that. It's going to take some time to get good at that. So that's the piece you really want to think about. So yes, Ray mentioned, array2.shift. Yeah, definitely array2.shift. I got that. I also got like 7 or 8 other bugs in there. I'm not even going to bother with that because I don't want you to do that. So take a look at the process, get your process down, and then start writing some code. Like we mentioned, write that pseudocode and then test that pseudocode. So that kind of idea of going back to what we were thinking for, how can I actually test that pseudocode? Go ahead and write that out and then think about what things that you need. Sometimes when you hear a problem, it's as simple as restating the problem in your own words. That also gives you a chance to figure out what data you might be working with. So maybe that is, okay, I have 2 arrays of words. I'll return each one in alphabetical order. Or I should return a new array with all the words in alphabetical order. Here, I'm making an assumption that I'm getting words. Maybe I'm right, maybe I'm wrong, maybe my interviewer doesn't care. Maybe my interviewer says, if you say words, let's do words. You say numbers, let's do numbers. But this just gives you a chance to clarify what it is that you are solving. Many times people are tempted to ask things like, What happens if I get past an array of Booleans? What happens if I get past no input? What happens if I get this? What happens if I get this? Most interviewers are not trying to trip you up with that. Most interviewers are not going to fail you because, oh man, Connie totally forgot that if you don't pass an array, it returns undefined. That's not really what it is. I want you to solve the problem. I'm not trying to trip you up with these little pieces and then get you at the end. You can always ask, can I assume valid input? That's the one question you have to ask, and that's it. You don't have to worry. Can I assume that they're always arrays of numbers? Can I assume they're always arrays of strings? Can I assume that they're arrays? Can I assume that they're not arrays of objects? Just, can I assume valid input? That's it. And 99% of the time, the answer is going to be yes, because I don't want you to write 10 if statements. I just want you to solve the damn problem. So usually it's just tell me that, and that's fine. So if your head gets in that point of like, oh, I got to clarify all those, usually you don't. It's always good to ask, never hurts, but it's usually not what someone is looking for. Make a test case. Again, you can draw this out, you can write this out, you can write some comments, you can literally say, I have a pen and paper right here, I have a whiteboard, I'm just gonna write this out, mind if I take a second? Great. The beauty of making a test case is you can now start to think about what you might need to do. I know that the first thing in this list and the first thing in this list, one of them is going to be the first thing in the new list. So that is just my basis for how to start. I got to compare apple and artichoke, and apple comes before artichoke in the alphabet. So let's go ahead and do that. We're smart people and we're good at solving problems. Thinking in code makes us dumber. It's not entirely true, but we're just going to pretend that it is entirely true. The second that your brain starts going to for loop, if statement, comma, semicolon, curly brace, there's actually just a different part of your brain that's going to take over. You kind of lose all of that critical thinking and problem solving, and instead you focus on syntax, 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 syntax. And there's nothing wrong with that, but just don't get there now. Focus on the syntax once you have a plan. Focus on the for loop once you know that you're actually looping. Focus on the while loop once you know that you're actually looping. Focus on shifting when you know that that's what you actually want to do. So sometimes conceptualizing, building some real world analogies, talking about it out loud can be really helpful. You can imagine you have 2 stacks of cards. These lists are just like stacks of cards, and I'm going to pick up one of these cards. And I'm going to pick up another one of these cards, and I'm going to ask which one comes first. And then I'll just put that card in a new pile. And then I'll go to the next card, and I'll ask which one comes first. And I'll put it in the new pile, and I'll put it in the new pile, and I'll put it in the new pile. Again, I'm not thinking about code, I'm not thinking about if statements, I'm just trying to build some kind of analogy for what I'm trying to solve. This doesn't work with every single problem, but for many problems, it can be helpful just to come up for air and just talk through what you're trying to do. This gets you to the pseudocode. Explain the strategy in English. Compare the cards, pick the earlier one alphabetically. Or if you want to get a little more technical, compare first items in both array, pick the lower ones. Once the array is empty, push the remaining cards onto the end. Granted, we'll add a little bit more detail in our pseudocode, but this is a really good place to start. You might be wondering, what happens if I just can't get all the pseudocode? So let's imagine that your pseudocode looks something like make a new array, loop over the first array, compare each value in the array to the other array. If it's less than, add it to the new array, and then return the new array. You might look at this and say, okay, I'm going to make a new array. I'm going to loop over the first array. I'm going to compare each value in the array to the other array. But if I look back at my test case, and I have 1 and 2, and then I have 2 and 4. Right now, if I loop over the first array and I compare each value in the first array to the other array, so I'm going to compare 1 and 2, and then I'm going to compare 1 and 4. That doesn't seem right. So maybe I'll just compare 1 and 2, and then I'll add 1. And then I'll compare 2 and 2. Oh, so I have to figure out, actually, after I compare, how to move across this array. Because now I'm comparing index 1 to index 0. Not totally sure how to do that. That's fine. Granted, I'm not going to be able to solve the problem if I don't know how to do this question mark, question mark, question mark. But sometimes solving the problem requires solving a simple problem first. It can be a real hurdle if you get to a problem and you look at a hard part and you say, I don't know how to do this, so I can't solve it. Start with the simple stuff first. In fact, even getting some code first to do what you want it to do. Because A, this is where your interviewer can help you out. This is also where you might get to it once you start getting to the code. Like the sorted lists. And now I have, array 1 and array 2. And I'm going to make a new array. And then I'm going to loop over the first array. So, I is equal to 0. I is less than array1.length, I plus plus. And now I'm going to compare each value in the array to the other array. So if array at I is less than array 1 at I, less than array 2 at I, then we're going to go ahead and add array 1 or sorted list, what array at 1 is. Otherwise, we're going to add array 2 at I. So add array 1 and array 2. I'm comparing each value and I'm seeing which one to add, but if that's the case, I'm now just going to loop to the number 2, and I'm going to compare 2 with 4, and I'm going to end up with this array that looks like 1 and 4. So right now, I can show you that through my problem solving, there is a bug that I am discovering. And what's great about this is where your interviewer could say something like, well, how can we make sure that if we choose one of these, we don't continue, or we change the length of what we're looping at, or so on. So this gives you a chance now, as the person solving the problem, to get some insight, to come in with a hint, to think about what to do. There are a zillion different ways to solve this problem. You can use a loop. You can use a for loop, a while loop. You could even use the sort function as well. There's just lots of different ways to do it. But if you can't solve the whole thing, just put in some placeholder. Because the last thing you want is just to spend 15 minutes staring at this saying, I don't know. Solve a simpler problem first. Test your pseudocode, and now you're ready to write some code. Again, what's the goal of this whole thing? Solve the problem before you think of the syntax. If I could just kind of summarize what I've been talking about for the last 40 minutes, it's basically just this slide right here. Solve the problem before you think about the syntax. Questions on this idea, this approach? Again, we'll send out some handouts for these slides. You can kind of have a corresponding guide to see this. So I'll make sure that you all get those after.
So basically, if you end up in one of those situations and you're just like, yeah, I don't know. I mean, you're finished, right? That's pretty basically the end of the line.
No, it depends. If it's a automated timed coding challenge and there's no other human, yes, that's usually how it works. So if it's I'm sending you a programmatic challenge on LeetCode, HackerRank, whatever it may be, you can't solve it, sorry, on to the next candidate or so on. That's why many companies just do an automated text screen at first, because it just filters out a lot of folks that can't do that kind of work. Whether that is a predictor of your ability to be a good software engineer is up for debate, and I don't necessarily think so, but unfortunately, that is just the nature of the beast. When you get to things like the onsite, when there's a human involved, there are sometimes problems that people will ask you where it's we have 45 minutes. I don't actually expect you to solve this in 45 minutes. Sometimes they'll just tell you flat out to start, I'm going to give you a really hard problem, and I want to focus on problem solving. And maybe you're going to get to a solution that's really inefficient, and then we can talk about how to get to a more efficient solution, but you might not solve it. That kind of idea of partial credit is totally reasonable when you're dealing with humans, but when you're dealing with, the clock and that's it, then that's usually the case. It's all or nothing.
I mean, generally, if you're dealing with an interviewer, their end game is basically, it's like, hey, I'm just trying to figure out what you know and what you don't know, right? Bottom line.
Pretty much, yeah. And also, I mean, there's, we talk about this a lot in our program, that there's the entire behavioral aspect of, do I actually want to work with you? So sure, you might figure it out, but if you don't figure it out and it's a, wow, I actually really like spending a lot of time with that person. They didn't figure out the problem, but I'm sure we could get them up to speed. Or honestly, I didn't figure out that problem when I interviewed, but I'll never tell anyone. There's a lot that goes into that process of, do you actually want to work with that person? So there's a whole other, part of this game that I think is very, very underweighted in the, how do I excel in these interviews? Quick question here, and then Jeff, I'll get to you. What if we spend a lot of time in the pseudocode and we don't have time left to implement it in code? It's not the most ideal, but I would still say it's better to have correct pseudocode and incorrect code than to have incorrect code and no pseudocode. So I wouldn't spend a ridiculous amount of time on your pseudocode, and the more time you spend practicing, the easier that's going to be. But just always make sure you have pseudocode regardless. Jeff, what's up?
So something I do to problem solve, and I just want to check if this is like a good approach, is I write it down on a piece of paper and then ask myself, how would I solve this without code? And I just like move numbers around, write it down. Is that a decent approach?
That's great. Yeah. As depending on the interview that you're in, you might want to start translating that to typing on a keyboard so someone can see it. Because the last thing you want is like, look at this amazing solution that I have here. And someone's like, I can't see any of that. So depending on the context that you're in, that, can be typing on a keyboard or your text editor or whatever it may be. That would be kind of the next progression there. But I got no problem with that. That's a great place to start. Forcing yourself to actually write things down forces you to be slower, forces you to think a little bit more. So I'm all for that. Again, how to practice. We'll learn the basics. There are zillions of places for the basics at this point. And then practice, 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 practice. Work on your problem solving process and time yourself as you solve problems. There's problem solving, and then there's problem solving, which is, I'm watching some TV in the background and I have Code Wars open and I'm kind of checking in and seeing what's going on and, whatever Netflix show I'm watching. And then, oh yeah, I guess I'll go back to solving this problem and I'll just peek at the solution to see if it's something that I should be doing. And, oh, the solution uses arrays. Yeah, I should totally use arrays. So I guess I'll solve this. And then an hour later, everything works. And you're like, cool, I feel good. It's kind of like studying for the test. And then you take a look at the answer key and you're like, oh, I totally would have got that. I think we've all been there before. It's totally fine. But when you really want to take this seriously, spend way less time. Just spend 20 minutes. Set a timer, look at a problem, spend 20 minutes, see how far you get. You got 30 minutes? Great. Just like kind of picking up any habit, just like you want to take care of yourself and get into physical fitness, no one's going to tell you start working out 3 hours a day every single day. That's just not going to happen. You got to build up that stamina and you got to build up that seriousness and rigor in study. So 20 minutes a day, 30 minutes a day, 40 minutes a day, in 2 20-minute increments, solving some problems. That's really all you need to start. It's starting with that consistency. It's building that habit. It's building that process that is actually much more valuable than I'm just going to cram for 16 hours in 3 days and then I'm going to crush this interview. Again, I think we've all tried to do stuff like that. And literally every single piece of educational research shows that that is not the way to do it. So sometimes we get lucky, sometimes it works, but unfortunately, it's just not very successful. Get your process down. Be the computer. We talk about this a lot in technical interviews, and we talk about be the computer. But let's imagine that we are asking you to write a function. We're going to write a function that is, something very, very silly here. So we're going to write a function to find the first odd number in an array and return it. So you might write your function, find odd number, and it's going to take in some array, and you're going to loop through, and you're going to loop over, every number of the array. And if that number is divisible or not divisible by 2, if its remainder mod 2 is not 0, then we're going to return that number. And let's imagine right now that, I just decide to do something like this. And then, let's actually say if otherwise, return false. It's a very silly function that is not great, but let's imagine that's what we have to do. So you go ahead and you start doing that, and you know, actually this feels good, and I'm just going to return false. There's a bug in this code. But when we talk about being the computer, if you were to say something like, I think this works, I would say something like, why don't you try this with an array of 1, 2, and 3? What is it going to return? If you look at this and you're like, oh, it's going to return 3. That's not what I want to hear. In fact, that is also wrong. What do we want to do? Be the computer. Okay, if I call this with 1, 2, and 3, I'm going to iterate over this array, and num is going to be 1. Then I'm going to check if 1, when divided by 2, has a remainder that is not 0. It does. Cool. So I return the number. So this should actually return the number 1. Okay, great. What happens right here? What does your function return? Instead of telling me, oh, it returns, 3, step through your code. This is going to feel a little slow and tedious, but this is what debugging is. This is just practicing for when things don't work. How do you figure out how to fix it? All right, so what is num going to be in the first iteration? Num is going to be 2. I'm going to go start looping, and 2 mod 2 is 0. So this if statement is false. And then, oh, shoot, I actually just returned false right now. I have a bug in my code. I'm returning too early. Let me go and fix that. And now I want to make sure that this return is happening outside of the for loop. By being the computer, you can avoid doing things like this. Okay, there's a bug here. Okay, let's change this. And then I'll console.log. Yes. And then if not here, I'll console.log. Lord help me. And then if not, I will console.log. Am I losing it? And then you find yourself just throwing console.logs, and then everything is just kind of like, what is happening? Be the computer, step through your code. Slow and methodical is just always, always, always more accurate. Read error message, log the bugs, start building that kind of muscle memory for, oh, I've seen that bug before, so I know how to fix it. Want to learn more? Well, we got a lot of things. We offer a free 4-night bootcamp prep course. We call this private prep. We have another one that's probably going to start in June. And it's a really great segue to, you've done some problem solving, you're interested in our coding bootcamp, come see us teach in a more kind of formal variety. So feel free to check that out if that's a good fit for you. And we've got lots of events happening on. We're going to talk about, I believe next week, we'll talk actually about layout and CSS and building some nicer web pages. So we'll kind of shift gears from problem solving and get more to building web stuff. So we'll do that next Friday. And we got quite a few coming up over the next couple of weeks.